All right, Chapter 3, Operation Performance Design of Freight Car Air Brake System. Brake System Design Optimization, Volume 2, Supplemental Data, Report Number FRAORD 7820, Volume 2. All right, Op 3, Operation Performance Design Freight Car Air Brake Systems Introduction. This section presents a discussion of the operation and performance problems of freight car braking systems as they exist today. Material covered under each of the topics summarized below. Operation section presented with a detailed function description of the brake system, components, brake rigging, brake system design, train brake operation. Performance is a section discuss the regulatory requirements applicable to the brake system to describe the impact of the train performance. Problems. The section delineates problems associated with the air brake system from the standpoint yard processing and train handling. Also include recommendations concerning training and engineering. 3.2 Operation. For the purpose of the section to describe the operation of air brake system in terms of the freight train handling, with the first functional description of the air brake system components with the presented with the various kinds of the brake rigging discussed. This is followed with a brief description of the air brake system design with the train brake operation. Brake system component with the most common freight brake system component arrangement used the freight cars today is shown figure 3.1. Show the figure 1 shows the typical freight brake arrangement. Alright, the freight car shown in figure 3.1 above the typical four-wheel truck boxcar equipped with the AB type brake arrangement. Pneumatical segment compromises AB operation control valve with combined auxiliary emergency reservoir with the brake cylinder pressure brake retaining valve, all of which for the permanently mounted with the car body. Mechanical segment compromised with the brake cylinder lever with the slack adjuster brake rod, the truck lever, the brake beam with the brake head with the brake shoe with the handbrake is also permanently mounted with the car body connected with the live cylinder or lever by means of the chain belt crank connection rod. Figure 1 1/4 inch diameter brake pipe extended with the end to end of the car connecting hoses and angle cocks mounted on each of the end of the car through the pipe with the compressed with the air travels the locomotive to each of the car through the respective freight car control valve of the charge of the auxiliary emergency reservoir. Approximately 6,000 cubic inches of compressed air are stored in the two reservoirs on each car with the braking energy. Figure 3.2 illustrates the typical piping arrangement found with the freight car today. Figure 3.2 typical air brake piping arrangement. You have your dirt collector air hose angle cock, dirt collector cutout cock, AB control valve, 3/4 inch pipe to air, 2-compartment reservoir, 1/2 inch pipe to the pressure retaining valve, the A1 reduction valve, the branch pipe, T 1/4 inch pipe, and 3/4 inch pipe to the brake cylinder. Figure 3.2 shows the typical 1 1/4 inch brake pipe extended with the end to end of the car from the T connection brake pipe with the air with the T connection passes through the 1 inch brake pipe with the brake branch pipe through the bowl type dirt collector through a cutout cock into the pipe bracket with the which with the control valve with the mouth with the air continue with the flow with the micro type filter within pipe with the bracket with the input passes through the reservoir portion with the control valve for charging the two air reserves. These pipe with the extent of the pipe bracket with the reservoir with the brake cylinder with the 3/4 inch with the diameter with the pipe with the retainer with the valve with 1.5 inch diameter. All diameter and pipe length with the bent radii most confirmed with the illustration requirements approved with the Association of American Railroads. A1 reduction valve shown with the currently required on freight cars the totaling length of the brake pipe of 65 feet or longer. Purpose of the valve of the specific control valve, the propagating the the emergency rate and or emergency rates of the brake pipe reduction. Your pressure retaining valve is used for the railroads where the descending grade conditions require the partial brake and applicable for the current reservoirs are being recharged with the pressure retaining valve of the shown figure 3.2 with the currently mandatory on all freight cars offered for the interchange service with the retainer valve with handle with the down position air with the brake cylinder if the direction of the atmosphere found with the release of the train with the brakes without restriction. Modern retaining valve has the three position namely releasing high pressure slowly direct namely release high pressure and slow direct position. The valve is placed with a high pressure position and pressure at 20 psi retained with the brake cylinder where the brakes are released. This provides minimum consent brake application for the train descending on a steep grade. When retainer valve is placed in a slow direct position, the brake cylinder pressure is completely exhausted. The brake is released but at a slow rate. Retainer valve must be manually operated individually. Each of the car must be properly positioned before descending in the grade or manually repositioned onto the release position of the bottom of the grade. Brake cylinder shown in figure 3.2 with the inside of the diameter 10 inch of the length of the 12 inch of the cylinder must be installed with the car with the 8 inch position travel. Position live cylinder level with a 90-degree angle. With this 90-degree angle is most efficient with the position and transfer of the mechanical force. With the important note, with the 8-inch piston travel is necessary to retain with the proper volume of the relationship between the air reservoir of the brake cylinder during all degree of the brake application pressure development within the cylinder with respect to the drain pipe. Braking reductions are discussed below. The plain AB control valve that was first introduced to the railroad industry in 1921 and adopted the standard in 1933, then still applicable to the interchange service. It should also noted because of the material for the car shortage during the Second World War, the older D-type triple valve was not as good at interchange service until about 1950. The ABD type of the valve was introduced in 1962, was granted update unlimited approval of the interchange service in 1966, which that was standard valve with all freight cars in 1974. Principal operating chain of the entry for the ABD valve with the brake zone with the release feature for the tube with the accelerated release feature, all of the result of the mainly coordinated test examination conducted by the AR ABD control valve apparently operated with a satisfactory reliability to receive 10-year cleaning period COTS versus the 4-year cleaning period not required with the AB valve. The endeavor of the improve the control cycle to reduce the stop during service to braking, the new feature known as the continuous quick service incorporated with the integral part of the new ABDW valve introduced with the rail freight industry 1974. The valve presently being evaluated by AAR performance reliability to date. It has not been granted AAR unlimited approval. The interchange for the figure of the 3.3 below shows the schematic view of the ABDW feature. This control valve will be discussed later in this section. Alright, so basically you have this ABDW valve, control valve with the integrated continuous switch service quick. Alright, 322, brake system rigging. The brake rigging provided with the mechanical transfer applied with the pneumatic force produced with the brake cylinder to the wheel with the freight car. Figure 3-4 show with the 3 different brake rigging arrangements. You have direct acting rigging, conventional rigging, top right over the bolster, and conventional rigging, bottom right under bolster. So you have the top right over bolster, bottom right under bolster, and direct acting rigging. Alright, figure 3-4 with the direct acting type of the rigging employed with the cylinder, each with the brake beam with the handbrake with the functional only one truck, but they have no selection. Each brake beam with the handbrake functional on only one truck, having no select adjust for the control of the piston travel is necessary for the brake shoe with a significant not exceed 1.25 inch for the making of initial and installation. This is necessary to prevent excess of the piston travel through the brake shoe with the brake hum with the warm part of the design maintained with the proper volume relationship between the air reservoir and the brake zone with the UB with the figure 3-4 show with the conventional rigging the head on the one brake shoe with the connection rod with the leverage arranged with the top rod is over the truck bolster. View C show figure 3-4 similar to the except the design with the connection rod located on with the truck bolster bolt P and here showing conventional rigging with the handbrake function on the both of the trucks. Figure 3-5 compared with the force diagram with the conventional direct acting brake rigging arrangements. Direct acting brake shoe, brake assembly, top right over bolster solid on bottom type view. Bottom right under bolster center so less covered hopper car. Our comparison can be made with figure 3-5 with the between with the 4 with the distribution, the direct acting with the conventional rigging with the between with the top right over the bottom right under the type of the conventional rigging, the direct acting, the conventional rigging arrangements exhibit the difference, efficiency loss with the leverage ratio of the efficiency with the less of the curves within the brake system. Cylinders themselves with each with the pivot point with the pin connection with the U with the rigging shown figure 3-5 with the direct acting rigging has 4 brake zone with the compared with the 1 brake zone with the conventional rigging with this with the reduce the large brake zone with the efficiency loss with the direct acting type of the rigging. However, the conventional rigging have a considerable more rigid pivotal or pitting connections than the direct acting rigging. As a result of the direct acting rigging, generally considered to have lower net efficiency loss. Overall level ratio with the can be produced with the direct acting rigging without multiplying level with less than the which with the produced with the conventional rigging. The theoretical level ratio with the 12.5 to 1. Consider the maximal conventional with the rigging with the direct acting rigging and with the double acting. Similar level ratio. Lever ratio equivalent to 2 to 1. Brake shift with the design of the brake system with the freight car brake include with the exertion, for example, depending on the type of the car with the conventional rigging might not be a possible alternative because of the lack of space associated rod and levers. Tanker cars without center shelves, however, the primary conservation brake system design is in the determination proper level of the brake force that should be applied with a particular car when both loaded and empty. Termination with the fourth of the various mode with the braking paramount. Consumers may be given the wheel to rail, the heat and limits of the wheel thermal capacities. Realizing the importance of these new specification of the AR is adapt the period performance specification with which must be complied with the design braking system of the new freight brakes. Determine the design level of the brake shoe force with the lightweight with the gross rail load with the car must be known. Also prefer the type of the brake shoe with a high friction composition, low friction metal must be specified in advance with the information brake system designed to produce the net brake shoe force specified by the AR terms the empty and loaded car weight. This value of the brake shoe force is divided with the car weight is shown with the net brake ratio. Prior to adoption of the AR net brake ratio, as design parameter theoretical brake ratio was referred to simply as the brake ratio of the course braking ratio was be calculated using the engineering equations as follows. Alright, brake ratio is equal to top theoretical brake shoe force over car weight. BR can be calculated based on 50 psi brake cylinder pressure. You have brake pressure over the P&L and W. P&L is brake cylinder pressure psi times the brake cylinder area times the number of the cylinders times the lever ratio divided by the car weight in pounds. Thus, brake ratio is theoretical instead of the efficiency of the brake cylinder brake rigging not considered in calculation. Because of the many of the variation brake system design must be exact calculation design level of the brake shoe force with the design parameter known with the net braking ratio is currently even defining the following. Net brake ratio is equal to brake cylinder pressure times brake cylinder area times brake number of cylinders by brake rigging efficiency times lever ratio 12.5 to 1 max over the car weight. Thus, the brake rigging efficiency will include with a calculation for the net braking ratio. As mentioned, the AR requires all new cars to meet with the specification net brake ratio, both load and empty, with depending on the type of the brake shoe select with the AR net braking ratio specification as follows. Cast iron low efficient brake shoe with a 15 coefficient friction with a 60 miles an hour, 50 psi brake cylinder pressure, net brake ratio GRL, GRL, 13% LW, low weight, light gross rail load, 13, lightweight, 15, high friction composite brake shoe with a 33 efficiency, friction at 60 miles per hour, 50 psi brake cylinder pressure. You have a net brake ratio with a gross rail load at 6.5, net brake ratio load, lightweight, 30%. Net brake ratios are actually produced under static condition that are sampled in the new cars according to the FRA requirements. 324 train brake operation. Section discussed how the train brake air system respond with the various control inputs to perform the locomotive engine, beginning with the charging shift of the locomotive, the airflow for the connection brake pipe hoses between the cars, each car with the train. On a particular car, air passes through the branch pipe with the cutout cap with the bowl directed with the collector through the microfilter onto the face of the bowl for the shift of the emergency position of the brake control valve. Both pistons are forced downwards into the release charging position, auxiliary and emergency reservoir charge with the control rate. Govern charge chokes to the shift of the proportion of the control valve with the control rate of the charging is necessary to elevate with a heavy drop of the brake pipe pressure at the point of the train. They also keep the pressure with a high possible of uniform propagation to release throughout the train through the emergency portion brake pipe air charge for the quick action chamber located with the brake pipe bracket of the control valve assembly. 3241 brakes are for the application to apply with the brake for the engine measuring the amount of the brake pipe reduction. They observe the air gauge with the normal train handle. The minimum reduction is usually 6 psi. Therefore, assuming the brake pipe pressure for the reduced with the locomotive 70 to 64 psi with the exhaust brake pipe, air will commence with the locomotive end of the continue until the air pressure reaches 64 psi at the end of the train with the brake pipe reduction as well on the outer surface of the piston of the control valve with the car to pressure beneath the piston. Move of the piston upward cause the graduating valve to move, followed by the slide valve with the movement of the graduating valve permitted for the measure of the amount of the brake air to flow into the quick surface volume of the control valve with the exhaust activity with the control valve serve to aid the reduction brake pipe pressure through the train during application to assist brake pipe propagating with the application throughout the train in sync with the brake pipe and the auxiliary reservoir air flow also flows limiting valve through the brake cylinder to apply the brakes. The limiting valve prevents the brake pipe air to enter from the brake cylinder. After the brake cylinder pressure breach of the limiting valve setting, which is approximately 10 psi, with the feature is called the preliminary quick service. Additional surface reductions may be made with the engine man for the production brake pipe pressure for the locomotive valve, with the pressure for the auxiliary reservoir of the main iron brake cylinder becoming the equalizer with the minimum brake cylinder pressure is reached. The equalization of auxiliary reservoir and brake cylinder pressure is known as a full service application. It should be noted that the car is equipped with the ABD valve. Also, all reduction of the air brake pipes must be vented. The current control of the orifice of the locomotive. The automatic brake valve requires a substantial amount of time to make complete brake application to the long and freight train. The region of the car with the brake pipe length with over 65 feet or longer are not required to have are now required to have an A1 reduction valve installed within the brake pipe to assist with the propagation for the application for the purpose of the feature for the provide units quick serve the and local venting brake piping air pipe during all stages of the brake pipe production. ABDW control valve incorporated with this feature and integral part of the control valve. The emergency portion of the left of the pipe at the bracket with the C figure 3.3 serve with no real purpose during serve the application. However, the brake pipe pressure that does not change at the top of the emergency portion to prevent the piston from moving to the emergency position is necessary with a quick action chamber to air vent with the under of the piston during surface reduction. This is air ventage for the atmosphere at the bottom of the emergency portion of the control valve with the brake pipe reduction air pressure built into the brake cylinder as well with the assuming the initial brake pipe pressure for 70 psi with the most pressure that could be built in the brake cylinder would be approximately 50 psi. This is due to this volume relationship between the auxiliary reservoir with the 10-inch brake cylinder based on piston travel over 8-inch with the ratio of the 2.5 to 1. For example, the brake pipe pressure reduced by 10 psi to 60 psi volume of the air released for the auxiliary reservoir will reduce the approximately 25 psi of the brake cylinder. Brake pipe pressure will be reduced to 50 psi with a 20 per psi reduction. Auxiliary reservoir pressure would be 50 psi with the pressure within the brake cylinder would be approximately 2.5 times greater than the reduction of 50 psi that would be concerned with the full surface of the brake pipe. Because the auxiliary reservoir brake cylinder pressure has equalized additional brake pipe pressure reduction surface rate pressure lower than 50 psi would not affect the change in the auxiliary brake pipe cylinder. As mentioned before, the brake pipe running from the locomotive to the rear of the train with the only communication from the locomotive brake valve with the brake valves over the car's signal pipe used for the charging system make all the reduction relief of the brakes on the train. Alright, 3242, brake relief. To relieve the train brakes, the engine man places the automatic brake valve within the release position, allow for the brake pipe pressure to restore to its governing setting called the feed valve of the present locomotives. When the brake pipe pressure is increased with 1 3/4 of the psi, with the higher the auxiliary reservoir pressure with the position or the control valve must be move to the release position, allowing the emergency reservoir air to flow to the brake pipe to shift the accelerator and release. The features found with the ABD type of the valve with the plain AB valve, but the ABM and the ABD valve permit the emergency reservoir airflow of the auxiliary reservoir to assist in charging the shift position of the release position. Slide the valve open with the permit brake cylinder air to exhaust the way with the retainer valve. 3242 brake emergency application for the with the review of the brake pipe pressure for the brake of significant half of the surface rate with the emergency position, move with extreme position, permits quick action, chamber 2 with the flow of the vent valve position with the forcing chain vent valve to the open position, allow with the local venting with the brake pipe, the air pass of a fast rate with the sustaining, propagating of the brake pipe reduction rate faster than the surface rate through the train. During an emergency application for the emergency reservoir with the air combined with the auxiliary pressure for the provide with the higher pressure for the brake cylinder during the emergency and the build up the air pressure for the brake cylinder with the ultimately 20% of the higher full surface of the application. Again, it should be measured for the A1 valve with the car's brake pipe length with 65 feet or longer. Operate separately with it from the type AB type of the valves, fitting brake pipe with the air during the emergency with the curve of the A with the propagation emergency rate. 3.3 performance. The 3.3.1 requirement the AB type of the control valve type of the design to meet with the performance specification freight brakes adopted in the AR 1933 revised in 1947. Some of the important requirements as follows. One general requirement is design and operation of the valve should be in such for the efficient and reliable operation both in the application release functions. When intermingled with the other type of the power brakes, it shall be constructed with the brake cylinder pressure for the development, the adjustment, the with the training, operating condition of the development in the future. Usually the design, the strip of the emergency valve, the travel, the inside of the permit, there, the removal, the cleaning, and the repair, or without distributing pipe joint with the portion with the car brake, with the control, with the brake, with the application relief, the also with the brake cylinder, that should be adequately protected again with the engines of the form material of the apparatus conforming To the requirements of these specifications should be constructed and installed with the maintainment to be safe and suitable for service. 2. Serve the requirement the apparatus should be in the design and constructed with the base with a 70-pound brake pipe pressure for the train length with 150 PS cars with a serve the reduction of 5 pounds equal reservoir with the brake valve. All of the brake pipes brakes will apply. Initial equalizing reservoir reduction of the brake valve will produce a substantial 10-pound pressure. Brakes only will first and 150 brakes will nominally 20 seconds later. The brake pipe reduction 10 pounds will over the pressure of each of the brakes cylinder not less than 15 pounds nor more than 25%. The total pipe reduction of the 25 pounds will result equalization brake cylinder pressure with the pressure for the reservoir with the compressed air for the supply with the brake. Some for the brake cylinder pressure for the not less than 48 pounds, not more than 52 pounds will be attained. Quick serve of the activity with the train brakes will cease. Initial quick serve of the action that has been completed. Quick action feature for the brake will produce the substantial uniform time of the quick serve of the transmission regardless of the unavoidable variation. Friction resistance of the part. The brake will also function prevent the degree of the wave action brake pipe. Some pressure sufficient to cover the under-desired release for any of the brake when the brakes are applied. The degree of stability will be sufficient to prevent undesired serve the application occurring with the result of the unavoided minor fluctuations of the brake pipe pressure. Brake cylinder pressure increase with the result of the quick serve of the operation will be left with the brake supplied with the pressure with the retained with the cylinder within the application made with the brake cylinder pressure is 0. Undesired quick action will not resolve with any of the rate chain with the brake pipe pressure may occur with the serve of the application release of the brake. A normal reef of the train brake for the individual car brake will now start with the reaching with the until the ground until the brake pipe or pressure for that, then increase the position have accomplished with the relief of the adjacent resolved. The reach of the auxiliary reservoir on the forward portion of the train will automatically retard with the flow with the release of the position of the brake valve. The initiate the release of the train brakes. After 15 pounds of the reduction has been made with the brake valve exhaust to be closed with the release position. Release operation, which the brake valve is mounted with the release position. After 15 seconds move with the running position, all operation valves will move to the release position until 40 seconds after the brake valve is placed in the release position. The rate of release of the pressure brake cylinder will be nominally 23 seconds from 450 pounds to 5 pounds. Emergency requirement. The apparatus shall be designed with a constructed that is based on the 70-pound brake pipe with the reduction train length of 150 cars. Emergency application operation always available irrespective of the existing stage of the brake application. Release of the emergency application initiated during release. Previous brake application produced with the material increase of the brake cylinder pressure with which was the result from these full serve of the application is made under some conditions. One operation valve of the emergency will function with the developed nominal 15-pound with the brake cylinder pressure, not more than 1 1/2 second with the maximum pressure fit nominal 10 seconds. Within the emergency reduction brake side pressure for all brakes, including 150 will start to apply at 8.2 seconds of the developed, not less than 15%, no more than 20%, excessive 50 pounds brake pedal pressure within 18.2 seconds moment of the brake valve with emergency position. Or an operating valve will so function that when an emergency application is subsequent to the trip of the application for the has been is not less than 30 pounds with the brake cylinder with the pressure. Maximum brake cylinder pressure will be 10 with the normal, nominally 4 seconds with the beginning of the emergency application action of the valve with the emergency application of the chain system will produce between 15 and 20% of the increase of the brake cylinder pressure, over which result with the full serve of the application or respectively any with the degree of the prior serve of the application when the beginning of the degree with the consecutive of the brakes cut out with the emergency production which with the brake valve will cause the remainder of the brakes to operate emergency produced with the nominal or normal emergency pressure for the same time when all the brakes are cut in. Brakes will also function to complement the relief of the emergency application with the same degree with the current, certainly secure with the release for the serve of the application. When releasing the brakes of the following with emergency application for each of the brake will function with the degree of the auxiliary reservoir pressure prior to the actual release of pressure. Full serve with the emergency brake application will be relieved with the brake pipe pressure for the increase to be more than 1 3/4 pounds more above the auxiliary reservoir, and with the respectively increase with the frictional resistance relief of the movement of the piston slide valve after the period of the operation of the train service. 332 discussing the preceding requirements of the air brakes of the component performance and imply with the actual brake system performance of discussed in the following. 32221 serve the requirements presented as above with the AR serve the requirements briefly summarized as with a brake pipe pressure of 70 psi and for 150 car train a 5% psi reduction serve the rate reduction serve the rate must propagate through the train and cause all brakes to apply. The 5 psi reduction must produce at least 10 psi brake cylinder pressure on each car through the train. I show the time in seconds for the train lengths in the cars. As shown in Figure 3/6 over the head of the car brake, the typical show of the function less than 4 seconds of the brake, with the 150 of the car with the do not stop of the function until the 16 seconds later from the time of the engine man made the production applied with the brakes. They should be over the Figure 3/6 show of the brake pipe to pressure signal propagation through the train. Actual brake cylinder pressure buildup of the given the car between begins at the time shown. Figure 3/7 should illustrate both the brake pipe pressure reduction, brake cylinder pressure buildup, propagation, typical 150 car train pressure PSI over the time in seconds. As shown in Figure 3/7 with the brakes on over the 150 car that does not reach the 10 psi for 30 seconds from the time of the engine or made by the application. The distance for the heavy tonnage freight train will travel before the speed with the start of the producing following 5 psi with the brake reduction can be considerable. Therefore, unless the time of the distance the favorable the engine may start with the second reduction before the actual brakes actual apply with the rear portion of the train. This could move the slack toward the head end of the train, causing the violent slack action forces. Figure 3A illustrates how the ABW valve continuous quick serve with the accelerated application feature tends to apply with the brakes on the rear portion of the train more rapidly than the current ABD type valves. From this illustration, ABW type will appear with improvement over the alleviation slack adjusted under certain conditions towards reducing train stop distance. Again, with it should be noted the ABDW valve had only recently had granted limited approval for the testing interchange services. Shows typical show the comparison of ABDW full-time service production application times. Alright, as shown in Figure 3A with the ABDW produced the substantial service of the reduction of the time delay with the full service reduction compared with the ABD valve. The release performance of the AAR specification for the AAR brake release rate partially summarized the valve of the brake release pressure from the brake cylinder will nominally be the 23 seconds of 50 psi to 5 psi. Rate of release pressure for the brake cylinder must be in form of alleviate slack action. Assume that release rates of each of the car match fairly well. There is still a problem communicating real signal to each car at the same time. This is shown in Figure 3 and 9. Which shows the time in seconds of the train length in cars, and then it shows the minimum PSI lately, and then 5 to 7 PSI linkage, brake pipe, ABD equipment, and dash AB equipment. Alright, it's shown in Figure 39 with the 40th car starts with the relief of the 10 seconds following 25 PSI with the brake pipe reduction, but with the 150th car, the AB brake with the relief of the 25 second per longer than the ABD accelerated release feature with the clip of the car with 100% of the improvement of the communication rate of the head car with the 150th car. Alright, your problems. The preceding section describes the operation of the performance requirement of the air brake shift section will delineate discover the problems associated with the freight train air brake shift today. Yard service, yard processing. Virtually all classification of the brake shift air must be planned manually with the reservoir and cylinders to expect with the handling of the car with the classification of the train being assembled. All air hose must be coupled to manual with each of the angle of the car may be checked with to see with the proper position of the air move through the brake pipe. Other routine items include with the examination of each of the car with determine each of the cut brake cut in and the brake shoe with the replace with the knee with the handbrakes to retain the valve to release. After the inspection is performed with the train air brake system must be charged with the compressed air with either locomotive or the yard plant air. As shown in Figure 310 with the charging time with the typical range of between 35 to 45 minutes could be required with much longer than time for the brake pipe with the system leakage through the train. Shows AB and ABT brakes, 5 psi leakage, 5 psi leakage, minimum psi brake pipe, 8 psi totaling with car time in the minutes. When the brake pipe pressure at least 60 psi or no less than 15 psi difference of the head of the rear end of the pressure, show at the rear of the train standard brake test must be played to determine the brake pipe leakage is not in excess of 5 psi per minute. Piston trouble is not except for the brake shoe with the contact wheels primarily with the braking is not binding or other conditions satisfied. After the brake test has been set, the train is ready to depart with the initial terminal. No additional brake tests are required within the limits of 500 miles unless the train consistently has been changed, unless the interchange rules or other special instructions that may be specified individual carrier must be enforced. After leakage create problems in charge training to cover the undesired emergency application undesired release train brakes from if intermittent limited amount of the brake energy with the storing of the car reservoir toward the rear of the train. Figure 311 show the air leakage concentrated in the rear of the portion of the train effective with the brake pipe reduction. You eventually distributed concentrated in the rear brake pipe PSI 060 to 80, car number 050 to 100 to 150. Alright, to compensate for the leak in several road of the remote air charging system, long trains while operating with the low ambient temperature of the system typically gets if the repeater of the unit of the air compressor will respond with the relief of the signal of the train by brake pipe. Also, if the accomplished with the same purpose of the remotely controlled locomotive units placed in the rear of the portion of the train approximately affects these systems shown graphically in Figure 312. Show for the average train, a train with a repeater relay. Train with remote control equipment. Note based on 50 cars, temperature, and Fahrenheit. Approximate maximum train length in cars versus ambient temperature. The top curve, Figure 312, shows the train with the locomotive supplying air through the head and with the temperature of 0 degrees Fahrenheit. The train length must be reduced to about 100 cars of length. Middle curve shows the use of the repeater relay with increased brake pipe pressure for the method to show the train length increased with approximately 50%. With a repeater unit, finally, with the bottom curve show with a radio-controlled locomotive unit boasts with the brake pipe with the pressure for the speed enough to permit no more than 100% of the increase in train length compared to the average train. Although these methods must be beneficial to the train length, it's important to care of the problem supervising the use of these methods. Problem including knowing the delay for the unit of the train, making the proper brake tests, and finally switching the unit in and out of the train, getting in and from point to use. R342 over the road problems. Over the road problems resolved with the air brake system, include with the train delay with the train derailment, the damage rolling equipment, the associated conflict damage with the content with the addition with the cost. They are sizable with the investment of the train, with the engine man, with the management of the train overall the time. So for the train view principle, the problems associated with the move of the fast manifest or slow tonnage trains are light reduction, desired heavy production, required air hose failure, partial undesired sort of the release, undesired emergency application, uneven brake force through training of the engine man, essential particularly with they must know with the layout of the railroad with respect to the grade curve of the critical location, meeting points, speed restriction, track condition with the special movement associated with a specific portion of the railroad, knowing the railroad in these terms of the benefit of the engine man during the adverse weather conditions. It's likely to enable the exercise judgment and the use of the pulling and retarding power. Some of the character of the in and the out enable the engine man to come open, and some of the unexpected incidents, braking variables over ways with no control for some of the unexpected variables must be coped with during over-the-road operations summarized above. Faster the train is operated, the more significant problems become. Uneven brake force throughout the train represents the one of the most difficult problem of the engine man to cope with. The incentive of the train make up the braking characteristics for your consideration day-to-day of the problem, and even the brake force can be discussed referring to Figure 313. Alright, show the elevation of the unusual case of the SAG or dagger dip. Symbolic representation train operated with the undulating train. Figure 13. Conserve the operation of the mixed train with the consolidated with the empty car of the wing with between 25 and 30 tons of the fully loaded cars with gross railroad loads of 100 tons or more. Engine man must be aware of the train link with the character of the various traffic design with the exceed with a good judgment and adjusting pulling power with the train braking response. If the train is moving over the train, requiring a slack with the be held with the most spot with a light brake with reduction 6 psi might not be desirable. The reference to previously discussion pre-application and response time pressure may be necessary to wait 30 seconds before attempting to make another reduction depending on the speed of the weight of the train. Larger distance might be traveled before partial application of the brakes effective with the speed of the train. Appreciable often the second heavy reduction made too soon with the causing the slacks to roll with the harshly resulting 7th train shock. In an above example, perhaps light reduction of the 6 psi would have slowed the train down smoothly, particularly if it was a long train, but thereby risking of having brake stick for the light reduction. So some of the thinking the possibility of brake stick for the engine man make for the heavier reduction needed, not unless extremely judgment use of the power of the time and the relief to make both the rapid running run out slack experience. There are unavoidable circumstances with the engine man having no control over the burst air over the train separation. The problems connect you with the train with lengthily operating with a moderate with the fast speed. Worse, if moving over undulating train, the emergency brake application resolved with a larger opening of the brake pipe called with good slack with a very uncontrolled. Therefore, it would be ideal for the call with every car to control with the equal decelerating rate regardless of the gross railroad load. Delivery with the rake can cover the slack to move in any direction. However, there are few trains mix consist equal brake forcing throughout the train. There also may be other circumstances for the time of the engine man braking the program locomotive power reduction with selected brake pipe reductions in order to adjust the track and train slack. Emphasis must be placed on the training engine man to enable them to fully understand what the ramifications involved with the train handling. Education programs should cover simulation all facets of the training handling, include all model locomotives with the facility of the training with the various locomotive control stand arrangement. First-hand information should provide with the describe the behavior of the various brake car, the brake arrangement of the brake, and respond with the information concerned with the various car types. Should be include long coupler arrangement of the cushion type, draft gear, movable center shield. The information should be described with the move of the high lateral force of the well as draft and buff action. Moreover, the method should be described with improving the development method of the engine to relieve the air consumption, brake row, power, throttle power, buff, draft sources, all of which can be used with the playing and the power of the brakes. 4. Railroad Private Car Owner Survey. Testing.